Hello everyone, welcome back. We're going to continue in Unit 2 now with ratios. I guess I should put an S. So, a ratio, guys, is just another way of talking about fractions. Basically, a ratio compares two quantities. So a ratio compares two quantities, either two numbers like, say, 8 and 4, or maybe two measurements like, say, 3 days and 12 days. Okay? Ratios help us to see important relationships. Okay? Helps to see important relationships between things. Okay. So, for instance, let's talk about the ratio between your monthly expenses to your monthly income. Let's say that ratio, expenses to income, is 10 to 9. Think of just a moment about what that means, and then we'll talk about it. So what that means is that for every $10 that you spend, you earn $9. Do you see anything wrong with this ratio? Unfortunately, too many people are in this position where they spend more money than they earn. Okay? Ratios can be written in 3 different ways. We could either say 10 to 9, or we can put a colon between it, so we could say 10 to 9. But what we do mostly is as a fraction, so 10 to 9. Now, it's very important which number we put as the numerator and which number we put as the denominator. When we are talking about things, the first thing that we're talking about is always our numerator, and the second thing we're talking about is our denominator. Okay? We can talk about length to width. If we have, I guess feet is, yep. If we have the same measurement, excuse me. So let's say I had 14 feet to 11 feet. Well, remember, guys, anything over itself equals 1, and feet over feet equals 1. So then we would end up just writing this as 14 over 11. When the measurements are the same, the measurements just go away because it's the same thing over itself. Now let's look at this, okay? Shane spent $14 on fresh vegetables, $5 on beans, and $7 on fresh fruit. We want to write the following ratios as fractions. So the first one we're going to talk about is the ratio of the amount spent on fruit to the amount spent on beans. Well, the amount of fruit is 7. And this is dollars. And the amount spent on beans is $5. Well, the dollars can go away and we just end up with 7/5. Okay, 7 to 5. Let's look at it again. Another one, the ratio of the amount spent on beans to the amount spent on vegetables. Well, the amount spent on beans is 5, again, dollars. 2, and the amount spent on vegetables is 14, also dollars. Well, again, when it's the same top and bottom, it equals 1, and so our actual fraction is just 5/14. We've got one more. Let's look at this one. The ratio of the amount spent on vegetables to the amount spent on beans. Well, the amount spent on vegetables is $14. And the amount, what was the other one? On beans. The amount spent on beans is $5. And so then we would have, and again, these are gone. And then we would have 14/5. Now these two 5/14 and 14/5 are very different fractions. So it's all about how we're comparing the two things that we're talking about. Okay? Let's go on. Ratios, just like any other fraction, always needs to be in lowest terms. Okay? So always make sure that your ratios are in lowest terms. So if we are talking, say, 60 days to 20 days, I don't know what about exactly, but let's say 60 days to 20 days. First of all, the days can go away because they're the same measurement. In this case, the zeros can go away. And the way I lower this, put it in lowest terms is, well, 2 can go into itself 1 time and into 6 3 times. And so my actual ratio for this is 3:1. Okay? So for every 1 day of something, 3 days of something else happens. I don't know what exactly, but whatever. You can come up with it if you want. Let's compare 50 ounces to 120 ounces. Okay? Again, our measurements are the same, so they go away. We can get rid of our zeros, and we are just left with 5 to 12. So for every 5 ounces of, I don't know, let's say olive oil, there's 12 ounces of flour. I don't know, something. But this is how ratios work, okay? Comparing two numbers, and we just do it as fractions. And we can have every kind of fraction just like we've been working on before. We can have mixed numbers. Let's say 2 days to 2 1/4 days. For every 2 days that I travel, I will stay in one place for 2 1/4 days, let's say. Again, these can go away, and in order to reduce this, okay, I have to change my mixed number into an improper fraction. So this is going to be 2 over 2 times 4, the whole number times the denominator. That's 2 times 4 is 8, plus the numerator is 1, so 9/4. Now, this is a fraction here over a fraction. So copy dot flip, remember the top, in order to turn it into a fraction, is 2 over 1. Copy the top one exactly like it is. Dot change the divide to multiply. Flip the bottom one, so I'd have 4 over 9. And then I would, there's nothing I can cross cancel, so 2 times 4 is 8. And 1 times 9 is 9, and I can't reduce that. And that's my actual comparison. Okay? So now let's talk just a minute about converting units. Okay? So not a lot of times, okay? A lot of times what we have, our measurements are not the same. So if we have, say, 2 feet to 30 inches, well, as long as these two, the feet and inches, are different, I can't do anything with them. But I can convert one of these to the other one. So we always convert the big one to the smaller one. I should say bigger one to the smaller one. So take just a minute, stop this, and decide, unless you know right away, which I kind of hope you do, which is bigger, feet or inches? Hopefully you said feet, and then hopefully you know how many inches are in a foot. If you don't, let's just take a look at this for just a minute. You can look this over and pause the video or whatever. Okay, so there's some conversions for you. Let's come back. So how many inches are in 1 foot? Well, 12 inches equals 1 foot. So if I have 2 feet, 2 times 12 is 24 inches, right? And then 30 inches. Now I have both inches in my top and my bottom, so they go away. 6 can go into 24 4 times, and 6 can go into this 5 times, into 35 times, and so we've got 4/5. And that's in lowest terms. That's about all there is really to ratios, guys.